just for reference, this is from the G.6, G.7 sheet that I posted on Edmodo for you. So let's go ahead and get started. We have two triangles marked as, or we want to know what would make them similar. Well, similar means two things. Sides are proportional. Okay, so the sides are proportional. Angles are congruent. So when we're setting this up, we want to write out and find out what sides correspond. So one thing that I learned from another teacher after having taught this already was writing the triangle statement, so the similarity statement. And so it looks like this. So ABE, and this isn't the part I learned. Hang on a sec, I'm getting there. Triangle CDE. But taking this instead and writing it on top of one another, because when you write them like this, CDE on the bottom, it gives you A and C are the same angles, B and D are the same, E is the same in both, AB goes with CD, and so on. So AE here and here is going to match with CE here and here. So I'm going to take AE and put it over CE, and then set that equal to BE, so that's up here, over DE. And now we can actually solve the problem. So AE is 8 and CE is 12. Whoops, I'm gonna need some room here. Let me fix that. Oh, whoops, hang on. Okay, there we go. 12, and set that equal to 5 over x, because that's what we're looking for. Cross multiply to get 8x equals 60, and then divide by 8 to get that x is 7.5. And so when you go back up here and look at the answer choices, there is your answer, C. All right, number 2, which could be used to prove that these two triangles are congruent, and you have two sets of information. Well, I want you to first look at the letters and notice that DC is in both of them. So what has to happen when you draw the triangle, which you should draw out the triangle. So here we go, DC, A. And then what I'm going to do is draw the other one, but see how this is the same? That means it's the same line right here, CD, except then it has a different vertex. Whoops, that was pretty bad. A different vertex over here. So we were given in this information that AC was congruent to BD, and that AD down here is congruent to BC up here, and then they share this side, so that automatically makes them the same. So this would be side, side, side. So A would be your answer. In number 3, we're doing congruent again. So let's go ahead and take this and mark up our diagram. So AB is congruent to DE, so there's that. Angle A is here, and that would be congruent to angle D, that's here. And then angle B down here is congruent to angle E over here. Angle, side, angle, right in a row. So there's your answer, C, angle, side, angle. All right, number 4. Which one cannot be used to prove that these triangles are congruent? Well, let's see. If we do MN congruent to PN, so if we do MN congruent to PN, oops, 2, that would be side, angle, side. That would make them congruent. So that one's not going to work. So A is out. If we take LM and make it congruent to OP, so LM and OP down here, we have side, side, angle. And that one, remember, if you spell it the other way, that would be your answer. It's not going to work. Now keep going, because I want you to understand how the other ones work, just as a refresher. So angle M is congruent to angle P. This would be angle, angle, side. So that one's good. So works, doesn't work, works. So it's not our answer. And then your last option would be angle L being congruent to angle O, and that one is angle, side, angle. So that works, which is not your answer. Number 5, which one shows that these triangles are congruent? Well, we have two angles marked as the same, and they share this side right here. So they share a side, which would mean that is the same in both of them, which makes this angle, side, angle. So C is your answer, angle, side, angle. All right, number 6. Now this one is this crazy proof and all this stuff, but what we need to do is just go through it piece by piece and fill it out, okay? So your given information is that BD bisects ABC. Well, to bisect means that it's going to cut this angle in half, which means each angle on either side of the bisector is congruent. ABC is isosceles and the base is AC. That would mean that AB over here is a leg, so this is a leg, and over here is a leg. And those have to be congruent because that's the definition of what an isosceles triangle is. So then with that, your last piece right here is that BD is the same, it's shared. So there's all of our information. So the second step, BD being congruent to itself, that is called the reflexive property. Okay, because it's just like a reflection. Nothing is changing. It's the exact same thing on both sides. So your reflexive property. So this would be number 2. All right, number 3, we're looking at angle ABD, which I marked here, and it's congruent to CBD over here. Well, we knew that because BD was bisecting that angle. And so if you look at this right here, that's your definition of angle bisector. All right, then we have AB congruent to CB. Well, we marked that, and the reason that we could do that was because it was an isosceles triangle. So there's your next step, that is your definition of isosceles triangle. Easy peasy. All right, so then now we have to look at how can we say that these two triangles, the one over here on the left, is congruent to the one over here on the right? Well, we have side, angle, side happening, and so that would be our last step. Side, angle, side. Oops, I didn't want to do that. I wanted to write a 5. There we go. All right, and then our last one from this section, before we move into the trig, is determining if these are similar or not. So, excuse me, what we need to do is set up proportions. We want to know if the proportions come out to the same number, or the ratios anyway. So you kind of just have to take a guess, set them up, and see if it works. So 72 over 12, so I took those two. I'm going to see if 84 over 14, and is that the same as 48 over 8? Okay, so I am checking to see if these are all equal. Well, if you divide them out, you get 6 here, you get 6 here, and you get 6 here. And what I did was proportions of the sides. And so since I lined up all 3 sides, that would be your side, side, side similarity. Now with this one down here, we have a vertical angle. So remember, those are vertical. And because they're vertical, they are congruent to one another. So since we don't have a third side labeled, we can't even use side, side, side. It's not even an option. We don't even have another angle marked in here, so we can't use angle, angle similarity. That's not an option because we don't have 2 angles. So same with this one here, we can't use angle, angle because we don't even have any angles. And we can't do side, angle, side because we don't have any angles. So you can eliminate answers really easily that way. So now I'm just going to match these up and see if they work. So 8 over 49, and is that equal to 14 over 28? Well, this comes out to some crazy decimal, so like I'm just gonna leave it. I don't even know what it comes out to, but this one over here, so this was a 49, that comes out to a 1/2, and those are not the same thing. So that didn't work, but that doesn't mean they're not similar. So I'm gonna try the other combination, which is 8 over 28, and is that equal to 14 over 49? And if you divide them, you get decimals, but it is actually equal. So this would be side, angle, side similarity. All right, and our next one here, so we have one angle, so that eliminates side, side, side because we don't have any sides. Again, because we don't have any sides, it can't be side, angle, side. And so we have 2 other options left. Well, we have a vertical angle here, And these being marked as 61 obviously means they are congruent. And look, there we have it, angle-angle similarity. Okay, and then with our last example down here, we do have congruent angles. Oh my goodness, I guess I have to have 4 arcs here, huh? So they have vertical angles here, right? So they have one angle in common. So one angle congruent. But then when you look at the other ones, we don't know because C is not marked the same as the other two. We don't have any side lengths, so it can't be either of these. And because we only have one angle that's congruent, we don't have enough information to say that they're similar. All right, so this one is your G, that's not a G, hang on, G.8. So your trig. We're going to work with the reference triangles first. And so here we have a 20-foot ladder leaning against a house. It makes a 60-degree angle with the ground. And so how far are the base of the building? So base of the building is down here, is the foot of the ladder, which is down here. This is what we're looking for. So you want to match up your sides. 20 is going to match up with the 2. And then your other side, your x here, matches up with the side between the 60 and 90. So 60 and 90 is here, so it matches up with 1. So we take 20, match it up with 2, set it equal to x over 1. Well, this right here is really just x, so 20 divided by 2 is 10, and that's x. So B would be your answer. Now, the second problem here, we have an airplane coming to land, and they're asking for the airplane to the runway. How far away is that? This is a 6, by the way, right here. And this is just Pythagorean theorem. 6 squared plus 34 squared equals x squared. Because remember, this is always your C. It's your hypotenuse, always, because it's across from your right angle. So 6 squared is 36. 34 squared is 1,156, which is x squared. This comes out to 1,092. But we need to take the square root of both sides. So when you do the square root of x squared, those cancel, which leaves you with just x. They undo one another. And then over here you get 34.5. Well, you'll notice that none of them are 34.5. However, if you come back to here, it tells you to the nearest mile. So that would mean you round it and make it 35. All right, now number 3, we have angle RST formed by RS and diameter ST. So RST here has a 30-degree angle, and the diameter, which is here, is 18. And we are looking for SR. So again, we need to match up our sides. So this right here is between the 30 and 90, so it's going to match up with that side there. And then our hypotenuse of 18 matches up with our hypotenuse of 2. So we set up x over the square root of 3 and set it equal to 18 over 2. Cross multiply to get 2x equals 18 times the square root of 3, then divide by 2. Now remember, at this point we can only divide these two numbers because 2 is not in a square root, so we get 9 times the square root of 3, which is C. All right, our next one. Now this one, remember your calculator, degree. So it needs to be in degree mode for this. And this one is trig, so you need your SOHCAHTOA. SOHCAHTOA. All right, so here's our reference angle. This is the side across from it, which is what it's asking you for. And then this one is our hypotenuse. So opposite hypotenuse, which means we're using sine. So we do sine of 40 equals, we take opposite on top and put it over the hypotenuse, 48. So we're going to multiply by 48 on both sides of our equation to get 48 times the sine of 40 and set that equal, and that equals x because that undoes one another. And when you actually multiply that out, you get that x is about 30.9. So there's that. And then your very last problem, all you do is plug this all into the calculator, and see if this equals 10 squared. And as you go through each one, this is the one that does not work. 8 squared plus 15 squared does not equal 17 squared. everything else does fit in the Pythagorean theorem.